Okay, Assalamualaikum. Okay, my name is Wan Wafi Akrami. Okay, we are from Stirling Group mini project. Okay, today we are going to demonstrate and explain about our group project, which is about Stirling engines. Okay, here is our prototype. Okay, before we go for further explanation, okay, I'm going to brief you guys about the basic principle of the Stirling engines. Okay, a stirling engine is a heat operating by the cyclic compression and expansion of air or other gas, which is we call the working fluid. At different temperature levels, such that there is a net conversion of a heat energy to mechanical work. Okay, this Stirling engine was first being introduced by the Robert Stirling, a Scottish inventor of a closed-cycle air engine in 1816. It was suggested by Fleming Jenkin as early as 1884 that all such engines should therefore generically be called Stirling engines. Okay, the Stirling engines is noted for its high efficiency compared to the steam engines. Okay, and it has a quiet operation and the ease with which it can be used almost any heat source. Okay, this compatibility with alternative and renewable energy sources has become increasingly significant as we know the price of conventional fuel rises, and also in light of concerns such as peak oil and climate change. Okay, this engine is currently exciting interest as the core component of a micro combined heat and power, usually we call CHP units, in which it is more efficient and safer than comparable steam engines. Without further ado, I will pass to my other teammate, Isaac Ramzi, to explain about the Stirling cycle. Amruddin Ibrahim is for the Stirling engine working part. Muhammad Faizal Ali for the heat transfer in Stirling engine. And the last part is will be presented by Hazrul Asfar about the overall working model.
Okay, Assalamualaikum. Now I would like to present about the stirling process, which is applied in thermodynamic. So in this process, we have pressure versus volume, and consists four process. For the first process is the isothermal expansion. The expansion space and associated heat exchanger are maintained at a high temperature. So the gas undergoes near isothermal expansion, absorbing heat from the hot source. So for the second process is the isochoric, which is a constant volume and heat removal. The gas is passed through the regenerator, where it's cooled, transferring heat to the regenerator for use in the next cycle. Okay, we go through the next process. Is number 3, is isothermal compression. In this process, the compression space and associated heat exchanger are maintained at low temperature, so the gas undergoes near isothermal compression, rejecting heat to the cool sink. So, and for the final process, number 4 is the isochoric, which is a constant volume and heat addition. The gas passes back through the regenerator, where it recovers much of the heat transfer into, so the heating up on its way to the expansion space.
Assalamualaikum. This is our comet stirling engine. It is consists of pressure chamber, working pistons, crankshaft, and load. In this pressure chamber, it contains displaced piston, which is pull the crankshaft downward. Working pistons act as output of the system. Heat will be supplied from the bottom of the pressure chamber, and the air will be expand the balloon, aka working pistons, and give output out from the system.
I'm Muhammad Faizal Ali, will explain to you about the heat transfer in the stirling engine. So basically, we will operate the stirling engine using the heat from the candle as a heat source. So we heat the plate here by the means of the radiation. Second, the heat will be transferred from this bottom plate to upper side of the bottom here inside the cylinder by means of conduction, heat conduction. So after the heat flow pass through the plate, it will be transferred again as convection heat transfer here inside the cylinder. So the air will be heated and expand, and it will go flow to the working piston here, aka balloon. So the balloon will be expand and give a work output out from the system. So this balloon expand due to the heated air. So when the piston here inside here there is a displacement piston. The displacement piston will be rise up by the work input from the load and flows the heated air here and expand the balloon. As the displaced piston goes down by the gravity pull, the cool air here will be forced flow to the working piston. So the working piston here, the piston here will be compressed and will be expand again, compressed again. So it give a rotational work just like this. Later on you will see the video about the operation of this stirling engine. So basically there is the exchange of heat and cool air here by the means of convection and conduction as well as radiation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Harwa from Shabri. I am the field presenter for this presentation. I will explain about how the mechanism of stirling engine and the process of heat transfer that involved in the mechanism of the working stirling engine. First of all, I would like to show you the video of working stirling engine. Okay, as you can see, the heat supplied by the candle, by the light over here, okay, is turned into a work of the working work. Okay, now, as you can see in this model, as explained by Mr. Faizal, this is a stirling engine. Okay, the heat will be supplied down here. The process that involved is the process of convection and the radiation. When I mean by radiation is that the radiation of the heat from the candle itself is transferred directly to the metal under the stirling engine, and then the convection from the chemical reaction from the hot fire and hot burning mixture transfer the heat from the burning candle to the bottom of the metal of the stirling engine. Next, as you can see in this diagram, in this part, the heat is transferred via conduction through the crossing the metal part of this bottom of the stirling engine. Okay, later, as you can see in this diagram here, the heat is transferred from the bottom of the part of this stirling engine to the air inside the stirling engine via conduction and via convection as well. And then the air inside the stirling engine will become hotter and it will flow upward, and then the cold air will flow downward, and then that will cause a temperature increase of the air inside the stirling engine, and then the air will expand. It will push the piston upward, as you can see, and then as the piston moves upward, the air will flow into the pipe here, and then the balloon will expand, and then shaft here will pull the crankshaft and rotate the crankshaft fail, and then as the piston has achieved its maximum height, it will fall back via gravity, and then the air inside the stirling engine will be cooled as well. That will cause the piston to fall down and contraction.
Main setengah.
That's all from our group, and about the presentation about stirling engine and heat transfer process involved in stirling engine. Thank you very much and good luck. Assalamualaikum warahmatullahi wabarakatuh.